Having this limit, that is limit as x tends to infinity of x all over x to the power of x factorial all over x to the power x. How are we going to solve it? If you move by direct substituting, infinity, you are going to have what? Infinity all over infinity, that is equals to infinity, and this is undefined. Okay, if you think about factorizing this? Can this be factorized? I don't think it will be easy to factorize this. Talking about L'Hopital's rule, if we talk about differentiating x factorial all over x to the power x, that is g of x factorial all over derivative of x to the power x. Do you even know how you can differentiate this? I don't know about a method used to differentiate this. Hence, to solve this amazing limit, you are going to use the squeeze method. Do you know about the squeeze method? Here is it. Let's take a background knowledge about factorial. If you have 3 factorial, what is the answer? Just drop in a comment. That is 3 times 2 times 1. Okay, if you talk about 2 factorial is equal to what? 2 times 1. And what about 1 factorial? That is definitely a 1, okay. And if 0 factorial, is that equals to 0? No, that is equals to 1. The question you're asking is, why is this happening? I'll just have a video up here explaining this in our next video. Okay, if you take a negative number, it can occur because factorial only exists for real positive numbers. Okay, let's move on. What if you think about removing this negative, this 1 at this end? Our answer will still be 6, and our answer here will be equals to 2, and that will change nothing. Okay, if you talk about x factorial is equals to what? X into x minus 1 up to the point we have a 1. Do you think about that? Yeah, that is it. Hence, the highest bound is infinity and the lowest bound is 1. That is infinity and moving to 1. Okay, let's take something a bit crucial. What if you have 3 factorial? Okay, this 3 factorial will be less than or equals to what? What if we just decided to not include them n minus 1, like as here? That is factorial. What is factorial? That is factorial of n is equals to what? N into n minus 1. What if we decided to remove this minus 1, and just keep what? 3 times 3 times 3 up to the point we have a 1. What if we just leave it like that? Figure it out. This probably will be greater than 3 factorial. Okay, hence this will be equal to what? Let's erase. Hence 3 factorial. If we take 3 factorial, that is equal to 3 times 2. This will be 3 factorial will be less than or equal to what? 3 times 3. And probably 3 factorial is 6, and 3 times 3 is equal to 9. Then hence 6 is less than 9. That's amazing. Okay, what if we wrote 1? This one that we removed earlier is less than what? 3 factorial, and this is less than or equals to 3 times 3. Okay, hence talking about x, therefore x factorial, let's move to the next screen. X factorial is less than what? Less than or equals to x times x times x up to the point, the last term, that is 1. Okay, and this can be further simplified as what? In mathematics, using the exponential form, this can be simplified to x to the power x minus 1. Do you believe in this? Yeah, just believe in that. Therefore, n factorial or x factorial has n minus 1 term. Yeah, that's amazing. Hence, the squeeze-through theorem states that what? That the factorial, like we have what? Limit as x tends to infinity of what? X factorial all over x to the power x. Therefore, using this principle we earlier stated, removing the 1, we are going to be having what? 1 is less than or equals to what? X factorial. That is less than or equals to x to the power x minus 1. Further simplifying this, let's come back. Okay, simplifying this to have x to the power x minus 1. That is how the squeezing theorem states. To further move on, we are going to divide all through by x to the power x minus 1. I use another pen. All over x to the power x. We divide here to x to the power x, so that it should look like our initial question. Okay, if from here now we improve, we introduce a limit, that will be limit as x tends to infinity of 1 all over x to the power x. This is less than or equals to what? Limit of x factorial all over x to the power x. That is less than or equals to, just write it here, less than or equals to what? Limit as x tends to infinity of what? X to the power x minus 1 all over x to the power x. You just see that this other part is the same thing as our initial question. It's as x tends to infinity. Okay. Hence, solving this will tend directly to 0 because 1 over infinity tends to 0. And at this other point, we are going to be having a limit of this. If you further simplify this, let's simplify this, that will be x to the power x minus 1. If we bring this up, we are going to have what? Plus, we are going to have minus x, sorry. Minus x. Minus x, that will be equals to what? X to the power minus 1, that will be equals to 1 all over x. Hence, at this other section, we're going to directly be having that is less than limit as x tends to infinity of 1 all over x, and this also tends to 0. Hence, in conclusion, we are going to have 0 less than or equals to what? Limit as x tends to infinity of what? X factorial all over x to the power x, and this is less than or equals to 0. Hence, this limit tends to 0 from lower and upper bound. Guess what? We come to the end of this amazing video. Bye.